So we have R and C, and then we will know على طول إنها RC صفر.
Yes.
لأن إحنا كنا نقول V out equals V.
ما شوفي الفرق.
Low and high.
أيوة. دلوقتي إحنا الأوت يعني اللي إحنا بنقيسه هنا على المقاومة. So in this case we have an RC circuit and the V out is on the resistor. Okay. لو كنت حطيت الدول هنا كان ال V out على الكاسة. Okay, so V in, you see the one that is connected to the power supply, and V out, if it's on R, then you have V out is VR, and if it's on this one, then you have
اللي هو هذا يعني فيكون على
شوفي تطلع من الأوسيوسكوب ده ال V in اللي بيوصل للباور سبلاي، وتاني واحد اللي هو ده ال V out. وعندنا ال V out على هنا ال V out على الآر. ال V out هو V out. لكن لو كنا موصلينه هنا كان ال V out يكون
دكتور نقيس الديفرنت عن الفيز.
The phase difference.
Difference.
لا في الاثنين في phase. You put it on ground. You make sure the two are on the same line. You remove the ground. Okay, you can make them bigger so that you see. And there is something that is not good in the connection. Yes, I want to show you the phase difference. Okay, just 1 second. I don't like the shape of the.
احنا ما حطينا فاليو بس هنا
Let's start again. So you have two signals like this. You put ground, and you make sure that the two are on zero, the same. Both should be on the zero line. You remove it, and then you zoom as much as you can. And it still needs to cross the line. Okay? يعني لو بعمل زوم كده دلوقتي ما بشوفش فين هم بيوصلوا للزيرو. So you have to come back. So you see this one crosses zero here, this one crosses zero there. If you want to make it clearer, you can increase the size. Then it will be sharper. Okay? And then you count the number of squares. 1, 2, 3, 4, 5, 6.4 in this case.
Doctor, they should be on the same scale, both of them?
No, it doesn't matter. This one does not matter. But it's just, you see, if it's flat, you don't see very well. If you make it bigger, it's easier to see where it crosses. The more perpendicular it is, the easier it is to see. But what is important here, you should use the biggest scale. So you could also get it with a very small scale, but you will have a big uncertainty. Okay, so 1, 2, 3, 4, 5, 6.3. Now I got 6.4, now I got 6.3.
Can you increase the scale for the V out and V in to the maximum?
Yes, you can. It will not change so much.
So which one is the best reading? Doing it like this or as you did?
It's about the same. You see 1, 2, 3, 4, 5, 6.34. That's anyway our uncertainty. We say 0.1 or 0.2. So it's all inside the uncertainty. Just what is not so good is when you have them very flat like this. It's okay, you can still read, but just here it's a bit more difficult to see exactly where it crosses. So if you make it bigger, it just becomes clear. Okay, this is the difference in time. You multiply this by the frequency, you multiply this, yes, you multiply, so okay, this is the difference in squares. You multiply it by the scale, you get the difference in time. You multiply it by the frequency, and you multiply it by 2 pi, and you get the difference in phase in radiant.
In radian?
It should not be more than about 1.5, 1.6, which is pi over 2. If you got more than pi over 2, you did something wrong.
Okay.